Welcome to Study Loop.
This is the answer to Chapter 23, problem number 73 from the Smith Organic Chemistry textbook. This problem says treatment of W with methyl lithium followed by methyl iodide affords compound Y, C7H14O as the major product. And then we're given spectral information for Y. We are asked to propose a structure, and then we are asked to draw a stepwise mechanism. Okay. So I've written everything on this first page that we've been given in green or in black, and I'm going to write what I do with what we've been given in green just to distinguish it. So the first thing I like to do when given a formula and asked to come up with a structure is to calculate an HDI. So 2 times the number of carbons plus 2 minus the number of hydrogens, all of that over 2. 14, 16, so 2 over 2, so 1. So we have 1 ring or 1 double bond in this molecule. Okay, so moving to the IR, a peak at 1713 wave numbers indicates probably a carbonyl. Well, not probably, definitely a carbonyl. Okay, so we have a carbonyl in this molecule. All right, so looking at the NMR, 0.8 ppm triplet integrates to 3. This is probably a methyl group. The next signal, 0.9 ppm doublet integrates to 6. This is 2 methyl groups. Okay, now we have a 1.4 ppm sextet with an integration of 2. This is probably a methylene. 1.9 ppm triplet that integrates to 2. Also probably a methylene. And then a 2.1 ppm septet that integrates to 1. This, to me, suggests an isopropyl group, perhaps. Okay, so we have a methyl group and then 2 equivalent methyl groups and a septet that integrates to 1. Okay, so all right, so I'm going to say that on one side of this molecule, we have this isopropyl group. So like this. Okay. And then, okay, so that 2.1 ppm septet is pretty far downfield. So I am going to say that that is attached to our carbonyl. So that would put our carbonyl right here. Okay. And then alpha to that carbonyl on the other side, we have a triplet at 1.9 that integrates to 2. So that would be this methylene group. Okay. And then the signal right above that at 1.4 ppm is a sextet that also integrates to 2. So another methylene group. 1, 2, 3, 4, 5, 6. That leaves us 1 carbon. So there is our methyl group. Okay, so just to clarify, so we have 1 methyl group. That's this signal. So that's here. The other, well, the next signal would be these 2 methyl groups. Our 2.1 ppm septet that integrates to 1 is going to be the proton here on this carbon. And then our 2 methylenes obviously are the 2 methylenes. But so this one would be the one at 1.9 ppm. Since it's alpha to the carbonyl, it's going to be further downfield. Okay, so let me just redraw this. Okay, so this is molecule Y. All right, So next, on the next page, we are asked to come up with a mechanism to get from W to Y. And so that mechanism is going to look like this. So we have an ester, and the first thing that's going to happen is going to be this. So the methyl group from the methyl lithium is going to add to the ester. We'll form a tetrahedral intermediate here. Let me move this down. Okay, so tetrahedral intermediate here. This oxygen has 3 lone pairs and a negative charge. Okay, and so now when this closes back down to reform a carbonyl, the bond between the carbon and the other oxygen will break. So now we will be here. All right. And we can draw a resonance structure that looks like this, based on this electron, or nope, drew it going the wrong way. Sorry. So based on this electron movement. Okay. And so now with that lone pair situated on the alpha carbon, it can now attack the methyl group from the methyl iodide like this. Okay, and so that is going to get us to our final product. And so here it is again. I guess I drew it upside down from the way that I drew it on the previous page, but that's fine. So this is product Y, and there's the stepwise mechanism by which we get to it. Okay, and then here again on the first page is the spectral information and the way that we piece together Y's structure. And that is the answer to chapter 23, problem number 73.